geometric system. And this is a logical system. It involves elementary logic. We have to start with some ideas which we call undefined terms. These are things that we don't strictly have definitions for. They're ideas that we know about. We describe them, maybe draw pictures of them. One thing is a point. So I have a point drawn here. So what is a point? It looks like a dot. Maybe that's the way we describe it. It looks like a period from our writing classes. Maybe that's the way we describe it. Something that doesn't have a linear measurement. In some higher mathematical thinking, we might say its elementary measure is 0. But this is a location in geometric space. In your algebra classes, you might have assigned an x and a y value to this so that we could define where it lives. So we have a point. A line is another one of these things. We can draw a line, and one way that we do that is we do something like this, put little arrows on there to show that it goes on forever in each direction. Something else we might try to show is a plane. So a piece of paper that you would write on, we might consider a plane, but really it's not a plane because that's a finite surface. A plane goes on forever in each direction, just like a line does. And so a piece of paper is an idea of a plane floating in space, but really doesn't give you that infinite idea. So the next thing that we need to have, besides the undefined terms, is some defined terms. So we're going to add definitions onto this, and so this is kind of a foundation, and then the next building block on top of this is going to be definitions. Alright, so definitions are next. So I mentioned space earlier. Space is the collection of all the points in our geometry that we're going to use, essentially. In Euclidean geometry, which is what you typically learn in high school, it's things drawn on the plane. You could symbolize this as a bold E with a exponent of 2. This represents a two-dimensional plane in Euclidean space. So we're focusing on a specific type of geometry here when we do this. And so we can define a great many things, and we use a great many definitions when we do mathematics and geometry. The next block to lay on our foundation is postulates or axioms. So we have the term axiomatic. That's the term axiom is playing into this. One of the older ideas is postulates. Either way that you have this, whether you call them a postulate or an axiom, these are kind of your basic truths. These are the ideas that you don't have to provide a proof for. They are just statements of fact about a system. And then from all these statements of facts and the definitions and maybe using some undefined terms, you're going to put these things together to build other logically sound ideas. So one example is what I've written down here in the corner. This is one of the most famous ones. This is known as the parallel postulate. So in plane geometry, this has been the make it and the break it idea. It's the make it idea because for years, and this is starting like 300 years before Jesus was born in Bethlehem, this was questioned by many people as whether it really should be a postulate or if it could be proven from other established of these postulates, these truths. And so it states that if you're given a line and a point not on the line in the plane, then there's a unique line that runs through that point that's parallel to the original. And it seemed kind of complicated, like it should have been built up of these more simpler truths. And nobody could prove this from the other ideas. What did happen is that when you alter this or throw this out, your entire geometry changes. And so this was a very important discovery that was almost overlooked because so many people were afraid to accept the idea of something new in geometry happening when we remove this idea or alter it. And so we get new types of geometry which you don't necessarily learn in high school, but have applications and neat results in other places. So postulates are kind of our game rules. So if you think about a sport, you have a list of basic rules to play that sport. That's kind of what your postulates and your axioms do. They tell you the rules for the particular mathematics game that you're playing. So in this case, Euclidean geometry, the type of geometry that you've learned in high school. So the next building block that we want to add onto here is going to have several things in it. We're going to add theorems and corollaries and lemmas, and these things have to be proven from these other ideas. So kind of capping off this foundation is theorems, corollaries, and lemmas. And these are all statements that need to be proven, and you have to use as support your axioms, your postulates, your definitions, possibly some of these undefined terms. A great example of one is the triangle angle sum theorem. This is one that you've heard about and maybe never questioned or never saw proven, but it states that the measure of the angles inside of a triangle are going to equal 180 degrees. So this is something that maybe your teacher told you at some point. You learned to believe it, you learned to use it, it helped you solve problems, it helped you understand triangles. But have you stopped to think where it came from? Have you ever questioned whether it was true, whether it's always true, whether it's only true in certain triangles? And so these are questions that we ask in mathematics, and we try to answer in a definite way. So there's kind of another term that's not here that's missing, and that's the term that we use for something that we think is correct, but we can't prove. And in science, you might call this a hypothesis. In mathematics, we call it a conjecture. You can conjecture something where you think it's true, but you haven't proven it. And so when you eventually go about coming up with a proof, and that proof works in all cases, then you consider that a theorem at that point. Before that point, you call it a conjecture, and then possibly it's not true, and somebody provides a counterexample which shows that it fails at some point. And so that's kind of disproving it. So that is something that is done in mathematics also, because sometimes we really believe something is true and something should work, but it turns out that it doesn't. And so these are two other terms that we need to keep in mind, that of conjecture and that of counterexample. Those two terms are important to us also. And these kind of run slightly outside of this foundation that we've built. The conjecture can eventually come up here and set on this foundation if it can be built up from these things, or if it falls completely outside of here, we provide that example that it's outside of what we have. So there are many postulates, and you can typically find these near the beginning of an introductory geometry text. They show up in the original geometry textbook that we have from ancient Greece that has come to us into modern times. We still have that available to us in a variety of languages. It's not just available in Greek, and that's called the Elements. It was written by Euclid, or composed by Euclid, and so that's still available to us. Many modern geometry books also have these other postulate statements as well, and we can start to develop these proof ideas from them. I'm going to leave you with a final challenge here. Can you prove this theorem? And I'll give you a hint. It's going to require the use of this postulate here. There may be some other ideas that you're going to need in that as well. This is something that can be physically done as well, and maybe that would help give you some ideas on how to write out the ideas that are required in a proof. You could cut out a triangle out of a piece of paper and try to work out the ideas there. For others, maybe you want to try to sketch a graph and try to formulate your ideas. Others that are more linguistically focused, maybe you want to try to write out a paragraph about how you would describe to somebody that there is truth to this statement using some of the postulates in your textbook, possibly this, maybe there's some other idea that you come up with. But your challenge is, can you prove this? You also might want to look at some of the initial exercises in your textbook and see if you can get a handle on how to use different terms and postulates, the undefined terms, the definitions. Can you look at given sketches and determine the kinds of answers to the questions that you're being asked? And if you run into problems, you should seek out further guidance. Perhaps talk to a friend, talk to your professor, possibly a website, another YouTube channel.